is a concept behind? So which unit covers this topic, why we answer certain way? Okay, so what is, okay, so it's better to have actually somebody else where selections of answers, questions. Okay, so what is free fall? Okay, so in which unit do we learn about free fall? So in which part of grade 12 physics we learn about free fall? So girls, are you here? Hala, Larin?
Yes, I'm here.
Yeah, right. Okay. So do you remember? So in which unit we learned about free fall? Does it relate to electricity, magnetism, forces, kinematics? So what is free fall? So anybody knows? So object is under the force of gravity only. And in another unit in grade 12, not only in kinematics, we learned about free fall. When object is in liquid, remember charge, how it was discovered the amount of charge in one electron. So electron, so drops were falling down. So also it's like free fall. So forces were balanced. Yeah, but it was constant motion. That's why like magnetic field is not related. So only under the force of gravity, object is falling down. So only in kinematics. Okay. Okay, so only Hala answered correctly. Okay, next question was on magnitude of acceleration due to gravity on Earth. Okay, so where did we deal with G? In which unit? So also in motion, right? So in motion, when object was moving in vertical direction, so force of gravity was going down. So acceleration of free fall always 9.8 on Earth. So on other planets, it's different. Right? Okay. What happens to the velocity of object in a free fall when it falls? Okay, so when object is dropped, so velocity is 0, right? And then every second velocity will increase. On Earth, it's every second, it will gain 9.8 meter per second. So V final equal GT, right? So acceleration of free fall multiplied by T. And then V final equal V initial plus GT. Okay, which of the following is possible for object with balanced forces acting on it? Okay, so when did we learn about balanced forces? So which physics concept do you need to apply there? Okay, do you remember which Newton's law we apply when forces are balanced and object is moving? So Hala, Larin, are you here? Okay, check chat. I think the second unit forces. Okay, so Hala, you have microphone off. Okay, I can't read all the time messages. Try to talk. Like Hala, is your microphone working?
Moving at constant speed?
Oh, okay, so is it Hala?
No, that was me, Larry.
No, I'd rather not, okay. Because I can't move after each question to switch screens. Okay, it's okay that noisy background, it's fine. Okay, so what do you think we apply when we answer this question? So balanced forces, and which Newton's law we can use when object is moving and forces are balanced? So remember first and second Newton's law. So in first Newton's law, if forces are balanced, object could be at rest or move with constant speed. It's what we apply here. And second Newton's law, if forces are not balanced, object will move with acceleration in direction of the larger force. Okay, so balanced forces is first Newton's law. So object could be at rest, so speed is 0, or could be moving at constant speed. Okay, so Lorraine, are you here? Do you understand what is?
Yeah, I understand.
Okay, so remember we were making like free body diagram for balanced forces. So if they equal and opposite, so in vertical direction or horizontal direction, so object will be moving with constant speed or stays at rest. So two situations. Okay, next one, you have free body diagram, right? So forces act on the object in vertical direction and horizontal. So you're pushing a coach, accelerate through the floor. So accelerate, it means right away, second Newton's law, forces are not balanced. Okay, one is bigger than another, and you have something moving horizontally. So you have force of friction, applied force, they're not balanced. Vertical forces will be balanced, object is not moving in vertical direction. Right, so why first one doesn't work? What's wrong with A? Who can answer? So why A is not correct? Do you see that in vertical direction, you have imbalanced forces and horizontally unbalanced forces? And you have object that is moving across the floor horizontally. It's not moving in vertical direction. So you can't move in at the same time, vertically and horizontally. Okay, so vertical is wrong. Okay, for B, also it shows that object is moving horizontally and vertically because unbalanced forces up and to the left. For C, okay, what's wrong with C picture? So why we can't select this picture? Because also you have forces up and down to the left and to the right, but why C is wrong?
It wouldn't move at the end.
Say it louder.
It won't move at the end because it has equal forces from all directions.
It could be moving. It could be moving. Forces are balanced. So it could be moving to the left or to the right. Or it could be moving, yeah, to the left or to the right only, not vertically. Because if it moves vertically, you wouldn't have horizontal forces. So it's applied force and force of friction. Look here, it's representation of first Newton's law. So if forces are balanced, object will stay at rest or moves with constant speed. So this coach is moving with constant speed, and we need to find when it's moving with acceleration. See, acceleration, so it means forces are not balanced. Okay, so C is moving but moves with constant speed, but D moves with acceleration, so horizontal force to the right is bigger. Okay, so keywords horizontally and with acceleration. Okay, question 6. Force that keeps object on top of surfaces instead of letting them sink into the surface. Okay, normal force, right? So it's force from the reaction from the surface. So you have textbook on the desk. So force down is force of gravity, force up is normal force. So normal force doesn't let object to drop down, right? And force of gravity and normal force will be equal and opposite to each other. Okay, hockey puck moves at constant velocity. What forces does the puck experience at that moment? Okay, because velocity is constant. Okay, so we are dealing only with force of gravity and normal. Okay, nobody is dragging, so no applied force. and we count friction is 0, right? So no friction, no applied force, so only force up and down. So it's ideal situation. Okay, so applied force, it's when somebody is dragging. Okay, so they just push it, nobody's dragging. And because constant velocity has no applied force, so no force of friction, ideal ice. Okay, so rough surfaces have bigger friction. And to reduce friction, we can use some lubricants or to put some water, right? So object will slide, less friction. So in some cases, friction is good. In some cases, friction is bad. Okay, so to reduce friction, we reduce mu. Okay, so Ted is trying to move a fridge across his house. He's pushing, but it's not moving. So what force is acting? So we are dealing with force of friction, and force of static friction is bigger than force of kinetic friction, right? So mu static is bigger than mu kinetic. So when object is already moving, so you need to apply less force than at the beginning to make it to move. So he's not moving, so we're dealing with static friction. So static is making it to move. Kinetic when it's already moving. Okay, and against him, so applied force is from the person. Okay, so he's pushing. So that is not correct. Okay, so only static friction prevents him to move the object. Okay, so you have distance and time. So somebody is jogging, and then person is walking. Okay, how to get average speed? So average speed is total distance over total time. Okay, so 18 plus 6, 24. 24 divided by 4 gives you 6. Okay, so total distance over total time. Okay, choose all ways object can accelerate. Okay, so when object is not moving on straight line, so when it changes direction and then changing speed, you're dealing with acceleration. Okay, so 2 girls answered right. Natalie drops her skateboard into a ball, speeding from rest to 4 meters per second in 2.5 seconds. What's your average acceleration? Okay, so acceleration is change of velocity over time. Okay, and units are important. You can have acceleration in meters. And when you do calculation, so 4 divided by 2.5, so change of velocity over time gives you that value. Okay, so units are important. So who made mistake here? Be careful with units. Okay, number 13. Okay, who wants to answer how to solve it? So which law we are using to solve it? Is Hala here? Is Larin here? So it's in the middle of grade 11, you learn about it. So how force and acceleration are related? Hello, Larin, are you here? Do you remember laws? Dynamics? So remember first Newton's law?
So we just times it.
Yeah, but why?
Mass times acceleration
And why?
to get the newtons, to get the force.
Which law?
Newton's second law.
Okay, and what Newton's second law is telling? When forces are unbalanced, what happens? So if forces are balanced, we had those questions at the beginning. Object moves with constant speed or stays at rest. If forces are not balanced, it moves with acceleration. And that acceleration is directly proportional to force and inversely proportional to mass. So acceleration equal force divided by mass. And more simple, like force equal ma. If m is bigger for the same acceleration, m is bigger, force is bigger for the same acceleration. But actually it's better through acceleration to deal. So acceleration is directly proportional to force. The bigger force, the more acceleration, and inversely proportional to mass. The bigger mass, the smaller acceleration. The smaller mass, the bigger acceleration. So it's like reverse, opposite relationship. So second Newton's law, forces are not balanced, object moves with acceleration. So force equal ma. Okay, next one. If object is simply dropped from elevated height, okay, and then which velocity is 0? Okay, so initial, because right away is dropped, so it's not thrown. If they will say thrown with some initial speed, then initial velocity is not 0. But here, initial velocity. So ball is dropped. Okay, dropped again. Initial velocity 0. So final speed is 50. How did it take for the ball to hit the ground? Okay, so how to get the answer? So anybody can tell which formula we use? What kind of motion is vertical motion? Can we apply formula for motion with constant speed in that case? D equal VT, is it applied here or not?
I use the equation V final equal V initial plus gravity times time.
Gravity times squared divided by 2, right? And because initial velocity was what? 0, you see it dropped. You need to rearrange that equation. So initial velocity is 0, so equation will be shorter one. So it will turn into which one? So remember formula how to find time when object is dropping down. Okay, you see my screen, right?
Yes.
Velocity is 0. So height or distance will be gt squared over 2. Now, how to get time? Both sides multiply by 2, divide by g, and take square root. So 2d over g. And then you plug. So height is how long it will. Okay, how long? Okay, so here I was thinking about
Yeah,
height.
I use time equal V final minus V initial divide gravity. Or acceleration, which is G.
Yeah, the final equal the initial gt. Yeah, and here it's 0. So time equal the final by 9.8. Yeah, and gives you 5 seconds, a little bit more than 5 seconds. Okay. Find force between two objects when they're so far apart. Okay, so which concept we are using here? So force of gravity between two objects. They could be in space, they could be on Earth, right? So gravitational force is proportional to g gravitational constant multiplied by product of two masses divided by distance squared. And what else we can use? Okay, so product of two masses multiplied by g, gravitational coefficient, and divide by distance between them squared. So it gives you that amount. So it's very small force because it's on Earth, very close to each other, but that force is there. So you will need to use gravitational constant. What is coefficient of static friction? If it takes 44 newtons of force to move box that has weight. Okay, so you have force of gravity, you have applied force, you need to find coefficient of static friction. Okay, so Hala and Loreen answered correctly. Okay, do you want to explain what you did? So you're moving box. You have forces.
I used F static over N, which is normal force.
To get mu.
To get the coefficient static.
Yeah, mu multiplied by Fn. Yep. And you have weight is force of gravity, F normal. So almost half. Yeah. Okay, makes sense. Distance between two objects increases as the pull of gravity, so it decreases, right? Because force will be inversely proportional to distance squared. Next one. You drop at the same time different objects. So what will hit the ground first? So both at the same time. Okay. It's like famous experiment with dropping object from Pisa. Galilei was dropping. Okay, so mass doesn't affect. Okay. Hot wheel toys race around the circle. You have radius, you have velocity. What is the toy's centripetal acceleration? Okay, so somebody answered. Okay, who answered? Hala. Okay, Hala. Okay, number 20. Okay, so what did you do to find acceleration? So v squared over r, right? Okay, and v squared, 1.8 squared. Okay, so 324 divided by 1.2. So 2.7 meter per second, yeah. So v squared over r gives you that number. Okay, 21. Okay, so you have mass, you have speed, how to get momentum. Okay, so what is momentum? Is product of mass by speed, right? So 50 by 5 is 250. Okay, Hala answered. So Loreen, so you see that just plug and chug. So momentum is mass multiplied by speed. And always check if they're in proper units. So if it's not C units, you change. So mass should be in kilograms, speed in meter per second. Okay, so collisions. So you have a truck moving at positive speed and another car that is parked. So it's not moving, so speed is 0. And then it moves at speed 15 meters per second after collision. What is velocity of the truck after collision? Okay, so what we need to remember, total momentum before equal total momentum after. Okay, so 3 answers correct. Okay, so you did it right. Okay, so law of conservation of momentum. Constant speed. So constant speed when distance between dots will be the same. Right, so it's both A, B, and C. Yeah, so distance stay the same. Okay, so always try to check to the end, because it could be not only one answer, like 2 or 3. Okay, I probably missed that it's at the end, all 3 of them. So the distance changes by the same interval every second. Okay, so slowest speed. Okay, the same idea. Okay, they all move with constant speed, but by the same time interval, one passes faster. So it's like somebody's making pictures. So every second moves bigger and bigger distance, smaller distance, and here the slowest distance every second only by shortest interval. So only B is slowest speed. Inertia, so it's not a force. Okay. More mass, more inertia, so it's first Newton's law. Tendency of object to resist change of motion is inertia. Yeah, so it's first Newton's law. Object will try to stay at rest. Okay. And the bigger mass, the more inertia. Units for energy, joules. So watts is not unit for energy. Okay, who can tell watts is unit for what? What do we measure in watts? Hello, Lorraine. So what do we measure in watts?
Joules?
Oh, energy we measure in joules, but what do we measure in watts? Remember how fast work is done.
Power.
Yes. Okay. So if you have joules per second, then you get watts, it's power. And when we pay for electricity, we pay in kilowatts per hour. Okay. There is a bell at the top of a tower, and you have height of the tower. You have mass of that bell. What is potential energy of the bell? Okay, potential energy depends from height. The higher the object and the bigger mass, the bigger potential energy. Okay, so it's mgh. So when you plug mass, acceleration of free fall, g, 9.8, or you can round till 10. That most of the time for fast questions, we use 10, not 9.8. And 45 with 3 zeros is closest number, that one. Okay, so this one is too small. So maybe somebody who was multiplying forgot g. So g on Earth, 9.8 or 10. Okay, so variable of experiment is the one being durably changed by scientists. Okay, so independent variable, we keep the same, and dependent depends from independent. So we are changing another one. Okay, what amount of sunlight makes pea plants grow tallest? What is independent variable? So independent amount of sunlight. Yeah, and height depends from sunlight. So height will be vertical and amount of sunlight horizontal. So it's basically when you do experiment, what is independent, like horizontally, what depends from it on the vertical axis. Kinetic energy, so energy of motion. So it depends from mass and speed. The bigger mass, the bigger speed, the bigger kinetic energy. It's like heavier car that moves with bigger speed has bigger kinetic energy. When a roller coaster car falls down the ground, what happens to potential energy? Okay, so when it goes down, height gets smaller. And because potential energy depends from height, it decreases. Okay, so it doesn't change the same. Okay, what will stay the same? So remember a law of conservation of energy. So when we talk about mechanical energy, so sum of kinetic plus potential, so total energy stay the same. So potential decreases, kinetic increases. Okay, so only total energy stay the same, not potential. Law of conservation of energy state the total amount of energy in closed system will always stay the same. So it's also one of the very important concepts in physics. So total energy in closed system stays the same. You have weight of the block and it's lifted 10 meters. How much work is done? Okay, so work is force multiplied by displacement and cosine of the angle between them. Okay, so if force and displacement are in the same direction, so cosine equal to 1, so we don't need to worry about this. But when it's angle between force and displacement, you use cosine of the angle. Okay, so you have force, you have distance, you multiply them, so that amount. Okay, now kinematics, so graphs of motion. So you have velocity time graph. So when velocity is constant, graph will be straight line. Velocity increases, line goes up, like positive slope. And the bigger steepness and the bigger velocity. If line goes down, it means with time, speed gets smaller and smaller and smaller. It means speed decreases. Okay, so horizontal line is motion with constant speed. Under the angle, speed increases. So positive slope, speed increases, negative slope, speed decreases. So object is slowing down. Okay, what we have for C, so C is horizontal line, so it's motion with constant speed. So time goes by, speed stays the same. Okay, so both girls, you made mistakes. So positive acceleration when you have positive slope. You see slope only for lines B and D, not for line C. Okay, so remember grade 9, slopes. Positive slope, line goes up. Okay, and negative slope when line goes down. So horizontal value increases, but y value decreases. So slope is negative. And for velocity time graph, slope is acceleration. Okay, so for C, slope is 0. It means speed is constant all the time. So no acceleration, speed doesn't change. Okay, motion of D. So D is a red line. So acceleration is positive. So speed increases with time. On this position time graph, what is velocity? Okay, so velocity for position time graph is slope of the graph. Okay, if I will make it bigger. Okay, so slope is steepness of the line. Okay, I'm trying to make bigger screen to see that graph, to show that graph. But it's basically you make right angle triangle, you find what is rise, what is run, and then divide them. So it's basically what you did in grade 9 to find slope. Okay, so here position time graph. So you make right angle triangle. So choose any point where you have integers for x and y coordinates, vertical, horizontal, and then change of y value. So change of x values gives you slope 5 meters. Okay, so slope of position time graph gives you velocity. Okay, velocity at 12.5 seconds. Okay, 12.5 is between 10 and 15. So velocity on interval B stays the same, 20 meters per second. So for 5 seconds, speed doesn't change, it stays the same. Force is vector because it has magnitude and direction. Okay, so both girls answered correctly. Quantity describes a magnitude but doesn't need direction. So it's scalar. So only number and unit, no direction. When car smashes into a bug, the force of the car on the bug is equal to force of the bug on the car. Okay, do you remember which Newton's law we are using in this case? Okay, so check which Newton's law we are using here. Is it Newton's law number 1, number 2, or number 3? So first Newton's law is law of inertia. And basically, if object is at rest, it will stay at rest. If object is in motion, it will stay in motion. 2, Newton's law number 2, if object is speeding up or slowing down, it's under some force. And why? Because forces are unbalanced, object will accelerate in direction of the larger force. And 3 is action and reaction. So even bug is very small and car is very big, it's still action and reaction. So car smashes into bug, so force of the car on the bug is equal and opposite to the force of the bug on the car. Okay, so forces equal and opposite. So magnitude is size, so it's number. So magnitude for velocity is how fast object is moving. Magnitude for force, how big is the force. So it doesn't have direction, so it's only how big it is, so size. Independent variable is on horizontal axis and vertical axis is dependent. Okay, for distance, so we use C units when we calculate any physics problems, unless it's like certain topic, like for, okay, not related to grade 12, but for grade like 9 science, for grade 11 electricity, so kilowatts per hour, so kilo and hours, but usually it's MKS, meter, kilogram, seconds, right? So meters is unit for distance. Unit for velocity in kinematics, so distance over time. So distance we measure in meters in C units, time in seconds, so meter per second. So both goals were correct. Acceleration is how fast speed changes. Yeah, so meter per second gives you meter per second squared. Object comes to stop in a problem. What's final velocity? Okay, it's not moving, so final velocity is 0. If King Kong falls off a roof, which velocity is 0? Okay, falls off, it means dropped. So it means initial speed is 0. So if it's thrown with some speed, then it's not 0. Okay, to be careful with words when you have vertical motion. Okay. And vertical motion, it's always accelerated motion because its object is under the force of gravity. How do you choose the correct equation when solving a physics problem? Okay. So choose equation that includes enough given variables and has one unknown variable. Okay, so always whenever we solve physics problem, we decide, okay, which concept is there, which formula could be useful, and then out of, so it should be one unknown, and we rearrange for that unknown. Okay, so basically what I see that could be some improvement. So I set up those quizzes to do 3 times. So Hala, you can try again, maybe you can make better. So we went through review. So try to complete even right now, because we need to submit reports and I want to see some marks that I attached to our report.